Somehow get the list of participants.
Okay.
I'm sure there are more people than registered people who are to come.
Okay, so
because this is needed for
from the Zoom you want Zoom or okay?
Just keep the list up because we need to, when we report, we should like how many people participated and so on.
Okay.
And outside the construction and all those things, you have to keep some. So if you keep the names, at least we know how many people attended.
Okay.
Matthew, we can't hear anything.
Can you hear now?
Yes.
Okay. Good.
But we missed everything before.
Pardon?
And by the way, we don't see the slides sharing. We see the we are just seeing the PowerPoint in the first slide.
Yeah, oui, oui, en fait, là, ils m'entendent moi et c'est moi qui fais le haut-parleur. Je sais pas pourquoi.
Yes, now we can see the consortium slide. Yes.
Yeah, this is all starting trouble. Okay, so to repeat again, so the TAPAS network was basically devoted to train, young, early stage researchers to on parts of multi and interdisciplinary skills that works at the cross section of speech processing, clinical practice, and industry. And we had about 12 beneficiaries that were consisting of regular speech technologies plus clinical research plus we had industry like Philips involved in that. And then we had also other partner organizations, caregiving organizations like in Bologna, industry and hospital, and we had what I mean is like we also had partners from Colombia, organizations who were involved in this project. So essentially, what TAPAS was focusing on was the basic thing was we wanted to develop big technologies for diagnosis, treatment, and well-being. Focusing on the well-being of a group of people for whom spoken communication is extremely challenging. This is what we want to focus on. And in that, we had three themes we were working on. So one was more going towards actually what's called early diagnosis of conditions, pathological speech conditions like dementia, depression, or even kind of monitoring health. The second theme was on kind of getting automated tools basically to for rehabilitative therapy to recover speech functions, or even monitoring the progression of disease such as Parkinson's and all over time, how we can monitor them in an obstructive way. The third was about redesigning current speech technology to work with people with speech impairments. And if you most of the people who work in speech technology observe that we have good speech recognition systems which are deployable today, but the moment we feed in impaired speech, this set of systems are going to have issues in handling. So so this is just an example there. So, so I just give a quick overview which kind of tells you what you're going to hear today, mostly from all the early stage researchers involved in this project. So in the first theme, we were actually focusing on things like how we can detect cognitive decline in dementia, how we can develop automatic methods and analysis and method to analyze, detect pathological speech. And here the focus was given towards how we can run representations, etc., from machine learning methods. And then how we can use like a speech and health is becoming a common, is emerging as a new area. And here how speech can be used for like remote or telehealth monitoring, and you will hear about work which basically focuses on how we can kind of estimate speed-based breathing pattern and how we can employ that to monitor health. The second thing was focusing on developing a personalized tools. So there are two kind of things where first was looking at how we can give feedback for speech therapy, and in that you can always ask to whom you want to give that feedback. So one was like, do you want to give it to the speech therapist? So how we can give them some kind of evidences to the speech therapist to follow a treatment, So that's where one work was focusing on phonological analysis. The other was kind of focusing more towards the patient side, where the idea was to develop virtual articulation therapies which kind of um, act like a speech language pathologist, basically to help people to improve the speech articulation and consequently intelligibility. Now, talking about intelligibility, that is one of the most important aspect that is in the speech, important aspect that is there in the speech, which is, if that is not there, perhaps we will not be able to communicate what we want to say as a message. Now, when we look at intelligibility, there are questions which are not so easily answerable here. For example, most of our notion of intelligibility, initial notions came out of telephony, where people were transmitting speech and they were asking whether you are able to hear the recognize the words and the sounds. And then people start with speech synthesis, and they said, okay, are we able to figure out semantically unpredictable synthesis synthesized from the speech and the synthesizer? But pathological speech is much more than that. For the question that you will see that in these talks, you will see that are the words even recognizable by human listener in pathological speech? This itself is a big question. So in these presentations, you will see like there are different kind of intelligibility measures. So what is the clinical relevance for them? What kind of deviations impact speech intelligibility? What would be a good procedure to assess speech intelligibility? And in addition to that, how we can apply kind of recent advances in deep learning for assessing speech intelligibility kind of thing. In addition to that, which is the talk which after my presentation, this is the talk where we will see like how to continuously absolutely track the state of patients with neurological diseases such as Parkinson's disease. Yeah. So this was focusing. The theme 2 was focusing on that, and the theme 3 was very focused on technological side there. So one of the work which we were trying to see here was how to give clinicians and patients an ability to basically listen to some simulations that kind of gives them an idea how treatment may affect their voice. For example, what happens after oral cancer surgery, how your voice may sound. So this may help like both clinicians and patients to take kind of an informed decision how to go about it. Then, as I was mentioned at the very beginning, today speech technology has made a lot of advances, but still, if you give them an impaired speech, you have issues. The recognizers are not going to be very accurate. So how we can actually improve dysarthric speech recognition or impaired speech recognition. And then there's another element which comes in is like how we can integrate some kind of gaming elements to help children's speech therapy. And also finally, like how we can assess speech production quality of cochlear implant is how we can speak. So this is the kind of the broad 3 things we are focusing on, and you're going to listen to them today, this day 1, and I'll stop here and give the platform to Emilio. Just to tell you that day 1 is focusing on this presentation, what the ESRs or the what's called early stage researchers have actually carried out this great research work inside this project. Tomorrow, what we will have is how we can take some kind of look forward, what kind of perspectives we can take from this work. And so here we take different views from early stage researchers based on their experience they gain from this project perspective. We listen to clinical perspective and what is the technological perspective, and we try to kind of have a what is called a discussion, a panel discussion, to basically to see what is the way to move forward in the future. And thank you all for attending this workshop, and enjoy the workshop. Thank you.
Thank you, Matthew, for your nice introduction, but apparently our online audio is not working well, so we have to solve that first. Can you hear me now online? still Julie talking?